So good evening students. So this is Raghavendra. So I teach chemistry. So today we will discuss a small topic which is nothing but buffer solution. So here buffer solution I wrote. What is buffer solution? So buffer solution is a solution which resists the change in pH value by the addition of small amount of either an acid or base. So buffer solution is defined as is the solution which resists change in pH value by the addition of small amount of an acid or base. Once you look at the definition, so here this buffer solution is a solution which resists the change in pH value. That means the pH value of this buffer solution does not change by the addition of small amount of an acid or base. That means here the pH changes little bit, but that is not considerable. So this is a buffer solution. And what is the significance of this buffer solution? So many reactions or many changes occur at a definite pH value. Let us suppose you take human body. The human body, so many metabolic activities occur in the human body that is at constant pH 5 to 7. See, if the pH of this human body changes, so definitely the metabolic activities will change. And here see, the buffer solutions you can see in day-to-day life also. The best example is the blood. So blood have a definite pH, But here in daily life we use many foods. We take many foods. Sometimes we may take acidic foods, or sometimes we may take basic foods. But whatever the foods we take, so definitely they mix with the blood. So definitely the pH of the blood has to change. But the pH of the blood remains constant. This clearly says that the blood is also one of the buffer solution. But here the important thing, it is very difficult to prepare the buffer solution. That means it is very difficult to prepare the solution which have a constant pH value. So let us suppose you take a pure water. So the water has a pH, pure water pH, that is nothing but 7. But when you keep the water in outside for some time, what happens? So the water dissolves the carbon dioxide present in the air and forms the acidic solution. So the acidity of the water changes. By the same way, when you take the water in a glass container, so definitely it dissolves some of the basic impurities and the pH value changes. So that means even though you take the pure water, so it cannot retain its pH for a long time. So that's why it is difficult to prepare the buffer solution. Okay. So now we'll discuss about how to prepare the buffer solutions and what are the different types of buffer solution, and the related numericals also we'll discuss. First we discuss about types of buffer. Types of buffer solutions. So generally buffer solutions are mainly two types. First one is acidic buffer. First one is acidic buffer. The name itself indicates acidic buffer is a combination of an acid which is nothing but weak acid and salt. That means this acidic buffer consists of an acid and a salt. So the acid is nothing but weak acid and salt. How this salt is produced? This is the salt of weak acid and with strong base. So remember one thing, students, here in acidic buffer the weak acid should be there and the salt that should be produced on the same weak acid with the strong base. We will give an example, CH3COOH and CH3COONA. So you can see here this CH3COH is the weak acid and this CH3COON is a salt. You know how this sodium acetate is formed. This sodium acetate is formed from the weak acid, the same weak acid. See, whatever the weak acid I took here, the same weak acid when reacts with NaOH, of course this is weak acid and this is the strong base, and you will get this salt. This clearly says that in this acidic buffer common ion will be there. What is the common ion, students? So here you can see the acetate ion and here also you can see the acetate ion. Of course, here H plus is there, here Na plus is there. That means in acidic buffer we can see the common ion in acid as well as in salt also, because so this common in acidic buffer, so the acid is weak acid and the salt is also produced from the same weak acid. That's why we will have the common ion in this acidic buffer. Next one is basic buffer. So this is similar to acidic buffer. In acidic buffer, weak acid will be there. In basic buffer, it is a combination of weak base and a salt. So here this salt is produced from the same weak base and with strong acid. Strong acid. Example, NH4OH and NH4Cl. NH4OH and NH4Cl. So you know NH4OH is the weak base and NH4Cl is the salt. How this salt is produced? It is produced from the same weak base and a strong acid HCl. So it is a combination of weak base and the salt of this weak base with the strong acid. NH4OH weak base and react with the HCl produce the salt, that is nothing but NH4Cl. So like that the weak acid is, acidic buffer is a combination of weak acid and salt with the strong base, and the basic buffer is a combination of weak base and salt with the strong acid. So this is about just types of buffers. Now we will discuss about the acidic buffer and the types. Apart from that, we will discuss about the calculation of pH of this acidic buffer by Henderson equation, and after that we will discuss the numericals. So now we will discuss about acidic buffer, students. So already I told you acidic buffer is nothing but combination of weak acid and the salt of the same weak acid with strong base. So acidic buffers can be prepared by direct method. You can write direct buffer. So direct buffer means here just when you mix weak acid and salt of this weak acid with the strong base, so this leads to formation of acidic buffer. Direct buffer, example CH3COOH plus CH3COONE. So this is weak acid and another one is the strong base, salt. And another one is HCOOH plus HCOONA, H3PO4 plus Na3PO4, H2CO3, Na2CO3, C6H5, COOH plus C6H5, COONA. So these are the some combinations of the weak acid and salt of this weak acid with the strong base. So here this weak acid is the acetic acid and salt of this weak acid acetic acid with NaOH form salt HCOONA. So here it is produced from the same weak acid CH3COOH and NaOH. So the another one is formic acid, it is weak acid and the salt is produced from the same weak acid H2OH plus NaOH strong base. And H3PO4 and Na3PO4. H3PO4 is the weak acid and Na3PO4 the salt of the same weak acid with the strong base H3PO4 plus NaOH. And H2CO3 and Na2CO3. H2CO3 is the weak acid and Na2CO3 is produced from the same weak acid with the strong base NaOH. And C6H5COOH and C6H5CONA is nothing but it is the salt, so which is produced from the same weak acid with the sodium hydroxide C6H5COOH plus NaOH. So all these examples comes under direct buffer. So here just you are mixing weak acid and the salt with the strong base. Sometimes we can prepare the buffer indirectly also. That means sometimes the combination of the two substances also give the buffer solution. Let us see. I am taking CH3COOH and NaOH. You know, the CH3COOH and NaOH produces CH3COONA plus H2O. If I take equimolar proportion, let us suppose if I take 0.5 molar CH3COOH and 0.5 molar NaOH, so then what happens? So this 0.5 molar CH3COOH combined with 0.05 molar of NaOH to form 0.5 molar CH3COONA. So that means here acid is completely consumed and base is completely consumed. So you will get only product, so CH3COONA. That means the resulting solution has only acetate ion. So it does not form a buffer solution. But when you take a different proportion, one of the compound is in excess quantity, another one is a limiting reagent. So that time what happens? See, let us suppose I am taking 0.5 molar acetic acid and I am taking only 0.1 molar sodium hydroxide. This is the initial concentration. Okay, but here as the reaction is going on, in this 0.1 m only reacts with 0.1 m NaOH, because so you know in a chemical equation same equivalence of reactants will combine. So here 0.1 m acetic acid react with 0.1 m NaOH only. And after the reaction what happens? So this concentration of this one is 0 and 0.1 m CH3CONA is produced. Then what about the acetic acid? Still 0.4 m acetic acid is remains. That means the resulting solution contains both salt as well as the weak acid. So weak acid will be there. At the same time the salt of the weak acid with the strong base is also there. So if weak acid is there as well as the salt is there, so that combination is nothing but acidic buffer. So like that, when you take the acid and base in unequal quantities, so if you take acetic acid as a excess reagent and NaOH is a limiting reagent, so there is a possibility to form the buffer solution. Possible.